This problem is very similar to the last, except instead of changing the plus c thing at the end, we're changing the number that's being multiplied by the x squared. So in this case, it's 2 times x squared. In this case, it's 0.5 times x squared. In this case, it's negative 1 times x squared. And then we have the base graph of just x squared here. And again, to graph each of these, I just used my calculator table. So I went here, and let's do just basic x squared again. So I'll get rid of these. And if I graph it, oops, I'm sorry, I'm looking for the table. I see the symmetry here, 9410149. Negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, etc. I plot those points. In fact, I think I only plotted 5 of them. And I got this graph here. Y is equal to x squared right here. I did the exact same process for 2 times x squared. When I went here, I just said 2x squared. And then I went to the table, found the points, and plotted those. And I got this graph for 2x squared, which is still goes through 0, 0, but it's a little thinner, right? A little steeper. Then I did 0.5x squared. That was the same looking graph, but just sort of more wider. And then I did negative x squared, and that was the same as x squared, but just flipped upside down. Okay? And so just like the absolute value graphs, these are very similar. Multiplying the number out in front by x squared makes the base graph y equals x squared wider or more narrow. If a is negative, it actually flips it over too. So that's all that does, just like the absolute value graphs. The higher the number here, the more narrow it is. The lower the number here, getting close to 0 makes it wider, and if it's negative, it flips it upside down.